Good morning.
Do you have anything for Veronica and I?
No, I don't.
Okay, sounds good.
Okay, hold on. Hello, Kaya. Bryce, what's Morgan doing? I was going to ask you that, and I forgot to ask.
She's at NDSU studying pharmacy.
Oh, okay. And how's that going?
I think it's pretty good. It's a lot challenging. It's like a lot more challenging, but yeah.
Because she can get everything there. I mean, she can get her doctorate there at.
Yeah, she's in a 6-year program, so it's like she's gonna have to go just all like in 6 years.
Look at those smiley faces. Do you recognize any of them in there?
I should. Some of them aren't smiling. How come not all of them are smiling?
I don't know why they're not all smiling. These are pretty crazy. I don't. Let's see. Where are some of these boys in here? There's some boys in here, but not too many. See,
That's a
look
lot.
at that little smiley face up there.
Oh my gosh. Aren't parents embarrassing, Kaya?
That's great. Well, I was gonna say, where's Brennan here?
You know?
Oh yeah. Brennan's right next to her.
See,
Yep, there's Brennan right
yep,
next to
see,
her.
this is just our way to get back from your terrible twos. It only lasts.
It was threes. It was terrible threes.
Yeah, it only lasts
twos.
till we die. Just to let you know.
I thought these were flash. Where's O'Brien in here? He's in here. There's not great. I'm pulling out here. Where's that? Oh, yeah, there he is. Hiding way in the back. They're good. There's Jack hiding
If
there.
you guys are
Only one
wondering
in the
why
white-
we're not starting, it's
only-
because Mr. Zaski's in here.
Only one. Oh, here. Look at these. Look at these pretty faces in there. Wait, they're too far. Too close. A little bit back. And then we've got all these smiley little ladies. I don't know who else is in there. Kaya's in there. Bryn's in there. I was trying to think if Dom, were you off?
Who's
the track?
between Kaya and Bryn?
I don't remember. I think Dom was in there. Brown had these. Oh, you saw him, right? First time. Yeah, I already saw him. Pretty fun.
And when you guys come back on Monday, Mr. Zaski's going to show the pictures of what he looked like when he was in junior high wrestling.
Ooh, I don't know. We'd have to really dig Kaya for a picture of that.
Okay, right, Kaya? Because Kaya works both ways, doesn't it? Right?
Yeah, I still had hair
Okay.
back then. Still had a mullet.
Yeah. So
That's what's up.
if I can show Karsha's mullet, mullets didn't exist when you just grew your hair long and mine fell out. So, all right. It was extra credit time. I think I got everything up to par.
You did?
Okay. I really believe that to be true. Okay. Now that I say that, we'll find out things. And if for the people that showed up at parent teacher conferences, that extra credit should be in. So you should see changes. So if you missed for whatever reason last night, there's still slots open for Wednesday. And if you're still interested in signing up and getting an extra credit, and if you're working with people and can somehow take a screenshot or a picture and get that to me, that'd be awesome. And the last thing, if you submit stuff, you can't submit it in that I don't know what it is. It's whatever the Apple format is. I can't correct it. Stuff doesn't come over across. And I'd like to say I'm losing my hair, but it's not happening. So I'm just getting older, Mark. Just it's getting terrible. Okay. All right, I'll quit complaining. So were we doing, maybe I need to do this first. I thought I had it on. Okay, let's get out of here. God, I hate it when I don't know what I'm doing. Okay, let's try this again. We got a lot to do today. Do you guys see this? Morgan, do you see this? Okay, awesome. All right. So was I given points yesterday? How far were we? I think we got stuck. Okay, if you got to here, this was worth 3/10. I wanted this for the last 10th. And I don't think I told you guys that. Where you have to have a negative 5x squared plus 1 in the numerator over 2 times the square root of x. Are you guys okay that if I have x to the 1/2 and you have the square root of x, they're the same thing? Right? You're all right with that, right? Okay. Number 3, if you have this product rule, I had x cubed times a negative sine x plus the cosine of x plus 3x squared. If you get that, you got a 1/10 of a point. And then if you rewrote it as a negative x cubed sine of x plus 3x squared cosine of x, you get another 1/10 of a point. Okay, I'll raise this up a bit. My fingers are nervous. My fingers aren't working. So this one will be worth 4/10 of a point. So if you took the derivative and expanded it, so in parentheses, you had x cubed plus 4x, and then the derivative in parentheses was 6x plus 2, plus then you wrote 3x squared plus 2x minus 5 in parentheses, and then the derivative was 3x squared plus 4, you get a 1/10 of a point. Then, if you FOILed and got 6x to the 4th plus 2x cubed plus 24x squared plus 8x, and then you FOILed this cubic and this binomial and got 9x to the 4th, 6x cubed minus 15x squared plus 12x squared plus 8x minus 20, which is a lot to say underneath a mask. You got a 1/10 of a point. Then if you combined like terms and got 15x to the 4th plus 8x to the 3rd plus 21x squared plus 16x minus 20, you got another 1/10 of a point. And then if you plugged in 0 and got negative 20, you got your final point. Okay, has everybody got that? Ugh. So I think the total comes to 1.2 points. So if you're in here and have paper, and you have a choice, people that are present, that aren't in the abyss. You can either put it in a piece of paper over there and I'll put it in, or you can email me your score, okay? People in the abyss, you just gotta email me your score. And you don't have to take a picture of it. Just email me the number, okay? Does that work for everybody? Sorry about the scribble. Have you been to this one? I love this one. You have a cabin up by this one? Olivia? You're the one who sent me that you have an Apple phone? You wanna fill it out? See, the reason Apple has that, that's what creates you get awesome pictures on it. You do. Okay, so go to settings.
That's okay.
So you go to. Photos.
Yeah.
Then you go to. Maybe it's camera. Yeah, and you got one fingernail, and they're two different colors. So go to formats, and you can change it back and forth. So what you want, high efficiency is at HD. Most compatible is what I need, which is amazing, because I'm correcting them on an iPad, which is an Apple product. And I can't locate anything. Okay, so then you go back and forth, so right before you send it to me, but that's, if we're in this situation, okay, come spring, you take the AP exam, okay, that, so you gotta know how to do it. So if you do it for me, that's.
Thank you.
I got them in the summer, I just don't wear them very often. You ready for it, Grandma? For what? For
Dizzy spells.
Yeah, I don't want
You know what's
to.
gonna happen?
Regard and splash.
This would actually be the greatest thing in the world, okay? Bryce, you know we all die. Okay? So since we know that, we might as well die being happy. Wouldn't that be cool? If I got a dizzy spell and tripped over one of those bags and broke my neck and died, that would be perfect. You guys feel it's really tragic and scary, but know that I died doing the happiest thing that I did, right? You understand what I'm saying?
Yeah.
I mean, I hate tater tot hot dish. I absolutely hate it. There's a story of why I hate it, okay? If somebody made me eat tater tot hot dish and I died, that would be terrible. You see what I'm saying? If I was doing a math problem and had a heart attack or a stroke and died, that would be wonderful. If I was holding my grandchild for the very first time and died, that would be wonderful. Okay? Well, there are old people that kids won't allow go hunting. Why? They might die. Why? They die being happy. Yeah, that's my point of view. Sorry about I got on the roll, but well, that's what you guys got to live with sometimes. And maybe I'll tell you the story somewhere down the road about why I hate tater tot hot dish, but I'm going to go. Okay, Abyssers, I sent you all the stuff this morning, correct?
Yeah, I got it.
Okay. And Ella, I'm going to have to recorrect yours. You got that?
Yeah, thank you.
So you got to be patient with me and don't yell at me and make me cry. Because I'm in that sensitive mood today, which happens when you get old. A lot of weird stuff, Olivia, happens when you get old. Okay. So this was, this is all you had to do. The derivative of this is 0. The derivative of this is a -9, correct? 1 times -9 is -9, x to the 0. Or you could think of it, it's a line, so the slope of the tangent coincides, they're going to have the same slope. I see people nodding. That's a good thing. Okay. This one is the only. See, I used to never do this. And I used to say, I figured if I gave you directions, you guys would do it the easiest way. And then I had people that, you know, once you learn a method, you feel you have to use that method for everything. That is a normal tendency. And I'm trying to stop you from doing that. You know, you got to figure out, when do I want to use, they're really tools, right? There's an appropriate time to use a screwdriver, and there's an appropriate time to use a hammer, right? It's not really good to take your hammer, Kaya, and pound in a screw. It's just not good. But on the same token, if you got to pound in a nail, a screwdriver is not very helpful. So anyway, this one you're supposed to do the limit definition. So I'm going to use delta x. You didn't have to. You could use h or delta x. So I had a negative x plus delta x squared plus 4 minus parentheses a negative x squared plus 4 all over delta x. Okay, so I need to see this limit start out this way. So that's what I was looking for. Do you have these parentheses? Do you have the negative sign in front? Some people didn't write these parentheses, and that led to chaos. Then I had to see appropriate algebra. You should know that the answer is a negative 2x, right? Just by looking at this. If you just write a negative 2x without any work, all you'll get is 1/10 of a point, which is better than 0. I agree with that, but not a lot. And so if your algebra doesn't match up with a negative 2x, I made a comment on that. So here's the algebra: negative x squared plus 2x delta x plus delta x squared. So this would be an h, this would be an h squared plus 4 plus x squared minus 4 all over delta x. So now this gives me a negative x squared minus 2x delta x minus delta x squared plus 4 plus x squared minus 4 all over delta x. It is now red pen time. By the way, I give away red pens if you're fascinated, as I am, about the elimination of variables. Okay? So just let me know. They'll be free. So those are the elimination, right? I have this term, this term. Those are the only two terms. I have delta x. I factor out a delta x. I get a negative 2x minus delta x all over delta x. Some of you factored out a negative delta x. That's not wrong. But when you simplify, it's going to be a negative 1, not a positive 1. And that's where a few of you fell apart. Red pen, Bryce. I'm actually a pacifist. Okay, I just do this for the inner 13-year-old boy that exists in my body. Okay, the limit as delta x of a, then I needed to see this limit. And I get a negative 2x. Bingo. All right, that's the work I needed to see. Boom, I'm done with doing limits. Now everything else is a shortcut. So it asks for the equation, which I bolded and underlined. Equation, Bryce, needs two things. What are they? And I got a point. So right away I could do this. X minus 4 plus 0.25. The equation of my, now I just need to figure out slope. So I'm going to take the derivative of this. F of x is equal to x to the negative 1 power. F prime of x is equal to a negative x to the negative 2, which for me, Bryce, is not very helpful in this format, okay? So what I do is I write that as a negative 1 over x squared. Now I know I'm going to put whatever x is, which is this. This is y, folks. This is x. We are going to have derivatives in which you sometimes put y in, that we're headed there. And sometimes both x and y, but right now it says the inputs have to be x. So I'm going to plug in 4. So f prime of 4 is going to be a negative 1 over 16. So here's a negative 1 over 16. I'm done. All right, a graph of f is concave down parabola. Now, a lot of you guys says, well, that's got to be x squared. It doesn't have to be x squared. Excuse me, a lot of you said it was a negative x squared because x squared goes up, right? This is what x squared goes up. Negative x squared goes down, right? It could be a negative x squared. It could be a negative 3x squared. It could be a negative 5x squared, right? It could be a negative 17x squared, correct? No matter what, whatever you take the derivative, f prime of x will be negative since, okay, I'm going to write this. Since, I should have wrote this. F of x is in the form of ax squared where a is less than 0, right? That gives you a downward parabola when that leading coefficient of the x squared is negative. You learned that somewhere along the line. I think probably when you learned about parent graphs from Mr. Karsh. Am I right on that? Okay. So we'll be negative since a is less than 0. Now you had to come up with a reason that was reasonable. Okay. And so the only one that has a negative slope, well, that's not even a line. That has positive slope. It's got to be 3, right? Okie doke. All right. A picture, you can't give me a picture. You got to give me these explanations in sentences. All right, Abisters? Number 5. Find the derivative. Notice it says do not do the limit definition. So g prime of x is going to be 3x squared plus 9. Done. Don't show your work. So I'm going to have to, there's a point here, isn't there? So my answer has to be a number. Dominic, that was sneaky on my part, wasn't it? It slipped in a point there. So I'm going to take the derivative of f of t, and a derivative of sine is cosine, so it's just going to be 3 cosine t. I don't have to worry about, you didn't even know the product rule at this time. But see, Noah, as long as this is a constant, I don't got to do the product rule. Because the derivative of 3 is 0, right? Don't even go through the effort. Plus 4. Because the derivative of 4t is 4, derivative of a minus 1 is 0. So now I'm going to plug in 0, and I get 3 times the cosine of 0 plus 4. AP, this is a non-calculator problem. Did I let you use your calculators? So you could have typed in the cosine of 0 and got 1. But this is a non-calculator. They expect that you know the cosine of 0 is 1. And so the answer here is 7. If you gave me 7 without any work, I gave you 1/10 of a point. The derivative of this, notice there's no point here, Dominic, is there? Okay, so I wrote f of x as 3x to the 1/2 minus 7 sine of x. The derivative of x is 3/2 x to the minus 1/2 minus the cosine of x. And that was good enough for me. Some people wrote 1.5 because you guys are anti-fraction. but that's okay. I've learned to deal with that. And some of you, a lot of you had the square root of x in the denominator, which was cool. Determine the points. So, Christian Lee, points are in the form of what? Give me an example of a point that's on a graph. Just make one up.
1, 0.
1, 0. Perfect. There's an x and a y, correct?
Yeah.
Yeah, I need an x and a y as my answer. So it says, at which graph has a horizontal tangent line? Kaya, what's the slope of a horizontal tangent line? One that goes like this. It's a special number. It can't be any number. So have you ever watched medical movies or medical TV shows? You're wondering what this has to do with calculus, okay? Let's say I fall and I hit my head, but Bryce, I don't die. You go to the phone, dial 911. They rush me to the hospital. They hook me up to this heart monitor that goes beep, beep, beep. And pretty soon it goes like that, okay? It's flat, right? What number represents? 0, because there are no heartbeats, okay? So that has a slope of 0, okay? So that means when I figure out this derivative, since it gives me slope, it has to equal 0. This is a formula that gives me slope, correct? I know my slope, it's 0. So I'm going to get my x values. I'm going to factor out a 3x, and I get x plus 2. So there are two x values that give me 0. 0 and a negative 2. Those are not my answers. I have to get y. This equation gives me y. So when I plug 0 in there, you don't have to figure out this math. I know you know how to figure out the math. You're going to say 0, 0. That's a point, just like Christian said. The next one is going to be a negative 2, and I'm going to put in a negative 2 here. I think I get negative 8. A negative 2 squared is 4. 3 times 4 is 12. Negative 8 plus 12 is 4. Those are my 2 points. You cannot graph it and tell me these 2 points and expect that to work. No, 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 no. The idea is, can you figure out the relationship between the derivative and the slope? We're going to be doing a whole bunch more of these kind of problems. Does everybody understand that? All right. Average rate. Average rate is the slope of a secant, correct? I'd need 2 points. So I'm going to figure out what f of a negative 1 is. And when I do that, I'm going to get a negative 2 minus 4. I get negative 6. And then I'm going to plug in and figure out what 1 is. And if I do that, I get 2 plus 4, which is 6. And then I'm going to use my slope formula because it's average rate. So it's 6 minus a negative 6 over 1 minus a negative 1, which is 12 over 2, which is 6. Bingo, done. This is instantaneous rate. So it means I'm going to take the derivative. And I'm going to get 6x squared plus 4. I'm going to plug in 0, and I get 4. And there's my answer. Average rate, instantaneous rate. Instantaneous rate is the derivative. Average rate is the slope formula, or what we call the difference quotient. This, two different continuous graphs with no derivatives at C. I try to give you a lot of hints the day before. You have one with a point. It doesn't have to be this one. You could have said this. You just had to draw something with a point, okay? These are the same graph. Does everybody understand that? They both have points. C is here, Olivia. They're not different. In other words, if I take this and jam this on my head, it's going to hurt. If I take my hand and slam it through there, it's going to poke right through my hand, which I've done. Okay? It does not feel good. Now, the other one is the one that creates a vertical tangent line. So when you draw this graph, I have to see there's a spot here where it's vertical. This is not vertical. You see what I'm saying? I have to see that somewhere down the line, it goes up and down. And so if it was kind of a poorly drawn, I understood where you were coming from, but it wasn't, or you didn't, or I did a poor job of explaining to you, hey, it's got to be vertical. That's why it's undefined. I took off 2/10 of a point, I think, maybe 3/10. Number 11, this proof. Did I skip one? Did I skip one?
No,
This one you just had a copy from your notes. So I could be really picky, right? Because you're copying it. So it's the limit. One of these days, not one of these days, we're going to have people actually. Cosine of x plus h minus the cosine of x over h. So the limit as h goes to 0. I believe this is the cosine of x times the cosine of h minus the sine of x times the sine of h minus the cosine of x. Am I right there, Jack?
Yeah.
Okay, good. So you have to interchange and then factor. I'm going to do that one line because I'm going to switch these two around, factor out a cosine. And I'm going to get the cosine, a negative cosine, excuse me. I get a negative cosine of h plus 1 over h and 1 minus the sine of x times the sine of h. Here's a 1 times an h. And so when I actually have 4 limits to figure out. This is going to be a negative cosine of x times this is 0. This is a minus sine of x. This is 1, and I get a negative sine of x. So that's what I was looking for there, something like that. All right, this one, what is C? C is 3. Even if you don't know the answer, take a shot, write down 3, maybe you'll be lucky, right? What is f of x? X to the 5th minus 3x to the 3rd plus 2x squared minus x minus 177. What's f of c? I believe you get 177. Am I right? Okay. If you take the derivative, the derivative is 5x to the 4th minus 9x squared plus 4x minus 1. And what is, when you put c in here, well, what is c? It's not 0. It's not 1. You guys don't get to pick c. You told me c was 3 up here. So you have to figure out what f prime of 3 is. I think it's 335. Am I right? Okay. That was the last one. This one was worth 1, 2, 3, 4, 5 points. So it was 17 points. I subtracted the number wrong from 17, and then I divided by 17, and then I moved the decimal place 1 spot, and I round to the nearest 10th spot, and that's how I get that score. So if you actually add them up and subtract them from 10, like we say in Wabasha County, you be wrong. Okey doke. Alrighty. Abisters, any questions? Cole Ackerman, everything okay?
Yeah, I'm good.
Cole, what'd you have for breakfast?
I had some Lucky Charms for breakfast.
Really? I used to love Lucky Charms. That's how I gained 85 pounds. By boxes and boxes of Lucky Charms. I'm gonna take those quizzes back. You know what I had for breakfast this morning? You care what I had for breakfast this morning? My wife asked me, I thought that was pretty nice. I said, what do you have for breakfast? I had a banana. I have a banana every morning. I have 2 eggs, because I love eggs, hard-boiled eggs. With a little bit of salt. I know I shouldn't have salt, but I don't have salt. And applesauce, homemade applesauce. All right. So do you have milk with Lucky Charms or do you just eat them dry?
You need to have milk.
Okay. So you're not one of these, you're not one of these persons that just snack on Lucky Charms. Huh?
No.
Okay. All right, we had notes, right? Did I give you guys the 2.4 notes yesterday that were not stapled? I am going to give you them today. Before you leave, get them, okay? Because they're up there, all right? But they're not stapled. And I can get them stapled. When they came up and asked me, is there anything to do? I knew there was something. That was this. I did have something for you. I failed to get these stapled. And I think there are 2 pages that have to be stapled. So we were doing 2-3, am I right? God, I did not sleep very good last night. And we were doing the product rule. Am I correct on that? And did we do these 3 problems already?
Yeah.
Olivia, I'm going to give you an oral examination. You ready?
Okay.
Okay. H of x is equal to 7x the sine of x. How would you do the derivative? And if you want to pass, you can pass because I only taught this yesterday, right? Do you see the 2? I'm going to ask you a different question.
Okay.
Okay. I'm going to call one of these functions f and one of these functions g. Okay. And then I'm going to ask you 3 questions. I'm making this up as I go. Okay. When you're an older brother, anybody in here an older brother? Okay. You know how you manipulate your younger? Do you have younger brothers or younger just? Oh, okay. So you ever play games with them? You know how you're supposed to win? So you make up the rules as you go? Yeah. This is me. Okay. So what's the name? So what f of x would be what function? That's my first question. What? 7x. Perfect. Okay. G of x would be what function? Sine of x. Okay. I actually have, since I'm making this up, I actually have 2 more questions. Okay. In your brain, are you able to take the derivative of that? Don't tell me the answer. Confident? Okay, like 90% sure? Okay. Are you able to take the derivative of that? That's the harder one. Okay, okay. Confident, 90% sure?
Yeah.
Do you know anybody who exists in the abyss that's in our class? Cole Ackerman.
Yeah,
You were picked by Olivia.
awesome.
Okay, so you can deal with that at a later time, all right? Are you confident in taking the product rule?
Yes.
Okay. What do you want me to start with?
7x
Yep.
times cosine of x.
Okay, I'm gonna stop right there. Olivia, is that the derivative of sine? Okay, she agrees with you, all right? Then what you want me to write next?
Plus
Plus
sine of x
sine of x,
times 7.
7, okay? Now, I would strongly suggest you bring that 7 in front of that sign, okay?
Okay.
Because otherwise, people make the mistake of taking 7 times x and then that's voodoo and that's really bad, okay? Done. Right? That's the product rule. Very good, Cole. Okay. So I'm gonna wait with this proof. Actually, I'm not. I'm gonna do it. I changed my mind. Kaya, does that drive you nuts that I changed my mind like that on huh? Are you okay with that? I'm not okay that I lose stuff all the time. I wrote it on a piece of paper, and that is probably the worst thing to do. I know what the paper looks like, and why am I not seeing it? Alrighty, I got it done.
Yep.
Alrighty. It. It. All right, I'm going to do the proof. All right, but before they do the proof, Jack, I'm going to ask you 2 questions. Okay?
Okay.
A long time ago.
Can you move the paper over a little bit?
Yep. So you can see it.
Yeah.
Okay. We wrote a limit definition for that. Do you recall it? And you could, yeah, do you recall it?
Like, what is the answer to it? Or,
How is the derivative of f defined
oh, yeah. what
as
is
a
it, like,
limit?
that and x n minus 1 or something like that?
Well, let's start out with limit.
Oh, limit.
Yep, limit definition. Not sure?
No, I don't really remember.
Okay, that's fine. Do you know anybody in the abyss? Abyss?
Bring cars.
Bryn Karsh. Do you know this definition? And you know what, Bryn, I set you up. I just had a feeling that was going to be a strong probability. So,
Is it the h approaches 0?
yes, it is. Marvelous. Okay. What else should I have over here?
And then is it f of x minus f of c?
No,
No, it's not that one.
because it's not a number. We're coming up with a formula.
F of x plus h,
Yes.
and then minus f of x
Yes.
over h.
Perfect. That's exactly what it is. Very, very good. Okay. Bryn, I'm going to ask Jack another question. Is that okay?
Yeah, that's okay.
Okay. It's kind of like tennis.
Yeah.
You see how there are themes?
Yeah.
that-
I knew that. I didn't know that.
Yeah, I know you knew that. I know you knew that. So I'm going to give you a chance. I know you knew that. What if I don't call it f? What if I call it the derivative of g? Would you be able to give me the limit definition of the derivative of g?
Would it not be the same thing?
Well, it can't be because it's g and not f. It'll look a lot the same, except there's a g and not f.
Okay. So lim as h approaches 0.
Yeah, that's okay. You can keep that the same.
And then g x plus h.
You want that in the numerator, I'm taking it.
Yeah.
Okay.
And then minus g of x,
Yep,
and then on the bottom you put h.
put h. Perfect. That's exactly what it is. Excellent. Excellent, excellent. Okay, so now I'm going to do this proof. Okay. So I'm going to take the limit as h goes to 0 of f of x plus h. Notice it says, notice that f and g are being multiplied together, right? So I need to have a g of x plus h minus f of x, g of x over h. Because that's the definition. And I'm really curious of what happens. How can I show that we come up with this from here? Now, Ari, what can you add to anything you want and not change anything? Zero, right? You know, if I've got $5 in my wallet and I add nothing to it, I still have $5 in my wallet, correct? Right? It's cool. I'm going to add 0 to this. And so I'm going to do a little bit of algebra here, and I'm going to do this algebra on the side. And so I'm going to draw a little thing right here, and I'm going to say f of x plus h, g of x plus h. And I am going to just do one little thing here because I would hate to be wrong. And I used to never have to worry about that, but I'm getting an older Jack, and sometimes, sometimes I forget stuff. And here's what I'm going to write. Oops, I'm going to put it in red. I'm going to move it over here so you can see it. So I inserted this red thing in between here. And so I'm going to write it a little bit nicer because I crammed it in. And I'm just going to do a better job. So I got f of x plus h, g of x plus h minus f of x plus h, g of x plus f of x plus h, g of x. So what I'm trying to say, Bryce, the thing in red is 0. Okay? And what I'm going to do is I'm going to break it into 2 fractions since it's got a common denominator. And this is going to be over h, and this is going to be over h. Everybody okay with that? And then what I'm going to do is if I look at this first fraction, do you see how I have f of x plus h here in both of these terms? Does everybody see that? I'm going to write this as f of x plus h. And I'm going to put a little bracket here. And I'm going to write g of x plus h minus g of x over h. And over here, I'm going to have plus. Here I have g of x in both of them, don't I? Right? Do you see that over here? So I'm going to factor out a g of x, Dominic. And in these brackets, I'm going to have f of x plus h minus f of x over h. Gus, are you caught up with me?
I am caught up.
Okay, Gus, what I'm going to do here is h is the same as 1 times h, correct?
Yep.
And I can do the same thing over here. Okay? So I'm going
Yep.
to come back to this side. And I'm going to write a limit. And I'm going to have the limit as h goes to 0. And I'm going to have f of x plus h over 1 times g of x plus h minus g of x over h plus g of x over 1 times f of x plus h minus f of x over h. And now I'm going to take those limits. And the only thing that's changing is h, correct? Would everybody agree? So in this first, right, I can do these as 4 individuals. Does everybody agree with that? I've done that before. I'm going to take the limit of this one first. Can I plug 0 in for h? Yes, I can, because 1's in the denominator. Does everybody see that? And I'll have x plus 0, and that's going to give me what, Jacob, when 0 goes in for h? Well, there's only a 1 on the bottom, just right here. F of what? F of x. This thing right here is going to become f of x. Now, Bryn, are you still there?
Yeah, I'm here.
I'm going to take my finger and cover that up. Do you see where I had the limit as h goes to 0 of g of x plus h minus g of x over h? Do you see
Yeah.
that?
Yeah,
I'm
I
gonna
see.
drop- Do you see that we've had that before?
Yeah.
Right here?
Mm-hmm.
So what do you think this becomes?
G prime of x.
G prime of x. Excellent. Now, Dominic, this doesn't even have an h in it, right? So it's not even affected. It's just going to be what? G of x. So Jack, I got to take 3 fingers here because this is too wide. I'm going to go like this. Do you see this limit?
Yep.
Do you see this f of x plus h minus f of x over h?
I do.
I'm going to look up here. Ah! What's going to be replaced here? F prime of x. There's our proof. Okay. But, I mean, the whole thing, whoever thinks of adding 0, right? But I needed this to be able to come up with those 2 things. So when those guys came up to that, you know, way back in the 1600s, that was pretty amazing, I think. I would have not have thought of that idea. All right. We're not going to do the derivative for the quotient rule, but I'm going to show you what the quotient rule is. Okay. Now, When do I use a quotient rule? When I have, okay, I have to have something that's in rational form. Okay? Does everybody see that? Darcy, do you see why this is called rational form?
Yeah.
Rational is kind of a fancy word for fraction, correct? It's got to be in that fractional form. And this term right here, first of all, this cannot be a constant. It has to be a binomial or more. So what I mean by that, it can be a trinomial, it can have 4 terms, but if it has a single term or is a constant, you do not want to use the quotient rule. Okay? Now here's what the quotient rule is. First of all, that's the symbol for the derivative. I start here on the bottom because Noah McDonald, I screwed up on this a lot. Okay? And so I had to have a way, because I was going to be a math teacher, right? I had to have a way that I was going to be successful in my classes. So this is the method that I used. And if you don't want to use this method, that's fine. You're not going to hurt my feelings. This is just mine. I just take that. If you look up here, it says whatever is on the bottom, whatever g of x is, just square it. So this is what I do. I write x squared plus 1 and I square it. Do not, don't ever multiply that out. That is a complete waste of time. It's better if you leave it like this because it's going to tell us more information in the future. And plus, haven't you guys noticed that time is like a commodity that you really want in this class? So don't multiply it out. Just write, this is G, this is on the, that's on the denominator. I'm just going to square it. And then what I do is I come up here and write it again in parentheses. So if you look at this right here, it says, all right, here's g of x squared. And the first thing you see up here, is g of x. So I start here and then I rewrite it. Then I know I didn't forget. Then what I do is I look at this numerator and I take its derivative. Notice here my numerator is f of x and I'm taking its derivative, right? So I'm taking its derivative, and what's the derivative, Noah Jensen, of 5x minus 2?
5.
5, perfect. Then it's minus. And if you notice up here, you're going to write f, and that's the function I just took the derivative of. So I'm going to write 5x minus 2. And now I'm going to take the derivative of of g, of this first term, or this first binomial. And core of that is what? Two x, perfect. All right, so now I just got to do a little bit, now I'm going to do a little bit of algebra. Again, I don't go through the hassle of multiplying that out. I'm going to multiply this as 5x squared plus 5 minus. So let's see if you can follow. I'm going to do a couple of things. The minus sign times 5x is a minus 5x. Would everybody agree? Times 2x is a minus 10x squared. Is everybody okay with that algebra? And then I have a minus times a minus. That gives me 2 times 2x is going to be a plus 4x. Ella, does that make sense?
Yeah, it does.
Okay. And so my final answer, again, I don't mess around with the bottom. And 5x squared minus 10x squared is a negative 5x squared plus 4x plus 5. And I'm done with that. Okay. I'm going to skip this one. I'm going to come back to it at a later date. I just got to watch my time. Okay. I'm going to come to number 3 next, which is the next page. So we know the derivative of sine. Olivia, you were 90% positive. The derivative of sine is? Derivative of cosine is? Everybody agree? We're going to learn another one. You are expected to have that one memorized, okay? Those two. This next one, you're expected to have it memorized also, okay? But Bryce, I never remember. Well, actually, that's false. I do remember this one, but I have a way that I can remember, okay? I know, and I'm going to write this over here, that k of x is equal to the sine of x over the cosine of x. I think everybody in here is okay with that. Kaya, are you okay with that? Right? You've seen that probably plenty of times. So what we're going to do is if we look at this, this is in rational form. So I'm going to use the quotient rule. Okay, Noah? So the quotient rule says whatever on the bottom, square it, and then rewrite it on top. Now, I'm going to look at what's on top here, Noah. What's the derivative of sine? So I got times cosine x, right? So this was g. I squared it. I wrote it up here. I took the derivative of sine and got cosine. Now I follow by a minus sign. And I'm going to write the sine of x because that's what's on top. Noah, what's the derivative of cosine? So it's times a negative sign. Haley, doing okay?
Yep.
Okay, so Haley, I'm going to ask you. First of all, I'm going to write the bottom like this. Are you okay with that? Have you seen that before?
Yep.
Okay. What's cosine times cosine?
Cosine squared x.
Okay. You see this negative here?
Yep.
You see this minus here?
Yep.
Are you okay that I change it to a plus?
Yes.
Okay. What's sine of x times the sine of x?
Sine squared x.
Perfect. You're doing wonderful, Haley. Haley, do you know what the cosine squared of x plus the sine squared of x is?
Is it 1?
Yes! Yes! Awesome! Over the cosine squared of x. Okay? Now, Haley, mathematicians don't like well, we like fractions, but we don't like answers in fractional form. Do you know what 1 over cosine is?
Is it cosecant?
Oh, it's close. It's not cosecant, though.
It's secant?
It's secant. Yep. So what is this one going to be?
So then secant squared x.
Perfect. Secant squared x. So the derivative of tangent is secant squared x. Okay. We're going to wait for these till Monday. Right? Because we got Wednesday, Thursday, Friday, Saturday, Sunday to forget all of calculus. And so when you come back here, you won't remember anything. Noah, you have a question?
You have extra copies of that paper.
Of the notes?
Yeah, like I have them in
Oh, did I give you these notes?
our class.
You didn't get that's what they're stapling right now? You didn't get
You still have to give them what you need.
I'm sure, you didn't get the 2-3 notes?
You give these.
Oh, shoot it. Bisters, I gotta get up. I am sorry about that. I should have yelled at you. I didn't. You guys probably told me this yesterday.
I have my own copy.
Yeah.
So what do you guys need? I'm really sorry about that. All right. We're at a point where this table is a lot smarter than me. So if you think you don't have something, feel free to get up and go look at here. You won't even bother. Okay? Since I'm up here, I'm going to hand out the 2-4. Does that sound okay? Since I'm on a roll, so now I'll know that I gave you this. Well, no, you won't. So I'll forget. So what I think is going to happen, if you've noticed, I probably scheduled a quiz and when your textbook homework is due, right? I think I have it for next Thursday. I'm probably going to move it till Friday, so don't be surprised if you see that change. Okay. Depends on how much we get done on Wednesday. So I still got 5 minutes, right? So I want to come back to this. And I want to do this problem. So here's the criteria for me going to do the quotient rule. Is it in fractional form? Yes. Is this not a constant? Yes. Is it a binomial or more? Yes. This is G. This is F. So now I'm going to take its derivative. So I deal with the bottom first. Heidi Danielson, what am I going to do with this thing right here?
Are you going to multiply by the conjugate?
No,
Oh.
the rule says this. If I back up and look at the rule, it says, where did I put it?
Oh, you're going to square it?
I'm going to square it, and I'm squaring a square root, correct?
Mm-hmm.
Okay, what does that give me?
X plus 1.
X plus 1. Perfect. So that's this squared, correct?
Mm-hmm.
What am I going to write up here?
Square root of x plus 1.
Yeah. Okay. I simply write this up here. Times what?
Times
You're doing
Three.
well. Yeah, great. Followed by plus or minus?
Minus
Minus, okay? Times, what am I
Three
gonna
of
have
X.
over here? Did you say it? I missed it. What's next?
Oh, I said 3x.
Perfect, okay? Now, followed by what?
It would be the derivative of g of x. So that would be
Right, so I'm gonna give you a little hint. It's the same as this. Correct?
mhm.
Ooh, this is not good. Well, we're gonna do it anyway. Okay, let's see if you can get it. What do you think it is? What if it was this, x to the 1/2 power?
1/2 x to the negative 1/2.
Yeah, it's gonna be 1/2 x plus 1 to the negative 1/2. Are you okay with that?
Mm-hmm.
So now we're gonna simplify it a little bit. Everybody okay in that process? This might be the part that's a little bit tough to see, but we're gonna come back to that later on. And I'm gonna have 3 times the square root of x plus 1, right, Heidi?
Mm-hmm.
Minus 3x over 2 times the square root of x plus 1. Would you agree with that?
Mm-hmm.
Okay. This has a positive exponent. This is positive. This is in the denominator. And because that's negative, that has to go in the denominator. So I got to get a common denominator. This is over 1, right, Heidi?
Mm-hmm.
So what's my common denominator?
2 square root of x plus 1.
Right. So down here, I'm going to multiply 2 square root of x plus 1, correct?
Mm-hmm.
And up here, I'm going to multiply it by 2 square root of x plus 1. You with me on that?
Mm-hmm.
Okay, so down here I have x plus 1. Up here, I'm going to have a fraction. It's going to be 2 square root of x plus 1 because that's the common denominator, right?
Mm-hmm.
Okay, so what is 3 times 2?
6.
What is the square root of x plus 1 times the square root of x plus 1?
X plus 1.
Right, in parentheses, right?
Mm-hmm.
Minus 3x, correct?
Mm-hmm.
Doing okay?
Mm-hmm.
So over here, we're going to have 2 x plus 1 to the 1/2 power. You'll see why I'm going to do that. I'm going to multiply by its reciprocal, which is x plus 1 to the first power, correct?
Mhm.
Right? When I
Mhm.
divide by x plus 1, that's the same as multiplying by its reciprocal. Oh, we'll finish this. You'll totally forget about this by the time I get back, but enjoy your break.